parallel lines. So this is just, we're actually going to spend some time comparing equations of lines and seeing if they're parallel. So if we look at these two lines and graph them, 2x plus 4, I start at 1, 2, 3, 4 up, and then I have a slope of positive 2 up, 2 over 1, or down 2 backwards 1, down 2 backwards 1, down 2 backwards 1. So this would be this line, and then, so this is blue. The other one's in green. I start at negative 2, and I have this positive 2 over 1, positive 2 over 1, positive 2 over 1. That is my slope there. So if I draw on those two lines, I have this one and this one. Let me neaten those up a little bit so we're actually hitting some points. Oh, except for, let's see, I made a mistake here. Down 2 backwards 1. So that's that one. Looks like we're pretty good there. Will these lines ever touch or intersect? So let's look at them, and what do they have in common? If you look at the equations for the line, you'll see that they both have a slope of 2. And if they both have a slope of 2, they will never intersect. Will these two lines ever touch or intersect? No. Because they are parallel, so they have the same rate of change. What do these have in common? Same rate of change, which is also called our slope, or slope. So they will never touch. Two parallel lines have the same slope. Write an equation of parallel lines. If you know a line passes through the point -3, -1, -1, 2, 3, -1. So I know it goes through this point, and it's parallel to the graph of y equals 2x plus 3. I'm just going to graph that. So I have a plus 3 to start in, and I go up 2 over 1, down 2 back 1. I want it to be parallel to this. And just by looking, I can see that I'm going to have to do this. It's going to be right side by side, right? So, but what do I need to know? All I really need to know is that on this one, m equals 2, and we said parallel lines have slopes that are the same. So I know what goes through this point. So I have the point -3, -1, and I have m equals 2, and I'm just going to do y minus y1 equals m times x minus x1, point slope formula. Y minus my y1 equals m times x minus my x1. Minus and negative is the same as big old plus a positive. So I'm going to change these both to pluses. So I have y plus 1 equals, distribute my 2, 2x plus 6. Subtract 1 from both sides. I get y equals 2x plus 5. Let's see if our equation was right. 1, 2, 3, 4, 5. Hey, we started there. And we'd go up 2 over 1 or back 2 or down 2 back 1. So that is the equation for our line y equals 2x plus 5. You try this one out and show the work and solve it. Again, all you need from here is the slope and the y-intercept. So I want you to put me on pause and then come back and look at the answer when you are done. So hopefully you got y equals 2/3 x minus 3 as your equation. What is the equation of a line that passes through 3, 1? There's our point, and is parallel to this line. You give this a try. It needs to be complete when you turn in your notes. So stop right now and do it. To use the point slope formula, y minus y1 equals m times x minus x1. What's the equation of the line that passes through this point and is parallel to this? Well, there's a problem there because I need slope in order to figure out how to do this. So I'm going to have to find the slope of this line. 6x minus 3y equals 12. Remember, to find the slope, I want it to be in this formula. So I can get that slope right there. So to do that, I have to get y by itself. So I have a 6x I need to get rid of by subtraction. Don't make monkey pines. We have negative 3y equals, I just have negative 6x plus 12. I can't combine those two. And then I have to get rid of my negative 3 in front of the y by dividing through every single part by negative 3. Those cancel and make a 1. 1y, or y, equals negative 6 divided by negative 3 is actually positive 2. And 12 divided by negative 3 is minus 4. So all I need from this equation now is the slope, which is right here. So I'm going to take this slope and this point, and I'm going to plug it into my point slope formula. Y minus y1 equals m times x minus x1. It doesn't say what if we want it point slope or slope intercept, but I'm going to assume slope intercept. Again, this minus a negative is the same as plus positive. So I have y plus 6 equals, distribute my 2, 2x minus 8, subtract my 6, and I get y equals 2x minus 14. So there's the equation of my line that is parallel to that 6x minus 3y equals 12 and goes through 4 or negative 6. Let's just look at an actual picture of a map. It says a bike path is being planned for the park in exercise 22. The bike path will be parallel to Main Street. So there's Main Street. And will pass through the park entrance. So it has to go through this point and be parallel to this line. So what do I need from that line? I need to know its slope. So I have to find where it goes through exactly. It looks like here. And here I'm going to erase my blue just to make sure. Yep, it hits an intersection of two lines there. And I would say here. So I would say if I drew my slope triangle, it would be up 2 over 1. So m has to equal 2. And I know it has to go through the point right here, which is 0 over and 4 up. So y minus y1 equals m, which is, 2, times x minus x1. So I have y minus 4 equals 2x. 2 times 0 is 0, so I just have 2x. Again, I need to get y by itself, so I add the 4. And you get y equals 2x plus 4. And that would be an equation of the line that passes through the park entrance and is parallel to a Main Street. That is it for parallel lines.